Hi, welcome back to the office, where today we'll be talking about the end of the world, a colossal squid, the world's largest radio telescope, and finally, some answers to some questions about sending nuclear waste into the sun. Firstly, I'm happy to report that since the last time we met, Earth has avoided complete destruction. Yay! First bit of good news is that asteroid 2012 DA14 is not going to come kill us all next year. If you haven't heard of 2012 DA14 yet, you really gotta get out more, because a couple of weeks ago, everybody from NBC News to the entire internet had their panties in a bunch about it. It's an asteroid about 45 meters across that was only discovered last month, and the fact is it will come really, really close to Earth, probably closer than any other asteroid ever has while we've been watching. It'll be here, not here, but close by on February 15th. But NASA's Near-Earth Object Program, which I'm thankful exists, tracks objects like this, and they said that it's not going to hit Earth. That's the end of the story, so yay. NASA calculates that it will come within 35,800 kilometers of Earth, so close that it will actually be within orbit of some man-made satellites. But DA14 is so small that you probably won't be able to see it with the naked eye. If you miss it, you'll have to wait until 2020 when DA14 is scheduled to return and again not hit us. So you can relax about that, but I know the other thing that you stay up late at night worrying about hitting the Earth. Black holes. Well, last week a team of astronomers said in the Astrophysical Journal that one of the best things that could happen to the field of astrophysics is a certain kind of black hole actually colliding with the Earth. Now don't worry too much. They're talking about primordial black holes, which so far are purely theoretical. They're thought to have formed very soon after the Big Bang, and if they exist, they're a lot tinier than the black holes that we generally think of. Probably a bunch of cold, dark matter with the mass of an asteroid, but the size of an atomic nucleus. Astronomers predict that if a small primordial black hole struck the Earth, it would pass straight through us, causing the equivalent of a simultaneous worldwide magnitude 4 earthquake that's just enough to rattle your dishes. But also enough to tell scientists that primordial black holes do in fact exist. Unfortunately, they think that if this happens at all, it'd only be once every several million years, so bad news for astrophysicists, good news for the rest of us. So quit worrying your pretty little heads about stuff colliding with the Earth, okay? Now I love me some megafauna, and there are very few fauna more mega than the colossal squid. In addition to being sleek and elusive and having the awesomest name ever, colossal squid have the biggest eyes of any animal, 27 centimeters in diameter, about the size of this basketball. But why? Bigger animals that live at greater depths don't have eyes nearly that big. Well, a team of biologists says that they think they know. In the journal Cell Biology, they report that colossal squids' huge eyes don't give them sharper vision. They just make them extremely sensitive to light and very farsighted. And that gives them an edge over its equally colossal predator, the sperm whale. So scientists think that colossal squids develop their huge, extremely sensitive eyes to detect whales far away and hopefully stay ahead in a kind of evolutionary arms race. You know what else I like? When a bunch of geniuses from around the world get together to figure stuff out, even when they're competing with each other. And that's what's happening next week, when astronomers from practically everywhere will meet in Amsterdam and start arguing over which country will be home to the world's largest radio telescope. Called the Square Kilometre Array, or the SKA, the project will include 3,000 different radio telescopes whose combined surface area will be, you guessed it, a square kilometer. In fact, the SKA is going to gather so much data that there aren't any supercomputers that can process them fast enough. This unprecedented data collecting power will help answer questions about the beginning of the universe, the role of dark matter, and maybe even whether there is extraterrestrial life. And of course, we'll let you know who gets the bragging rights to be the SKA's home country. Third, I always like being reminded that we are more alike than we are unalike. To give a hat tip to Maya Angelou, This week, scientists say they've discovered the first genetic evidence of prehistoric gene flow between Africa and Europe. The study focused on the DNA in our mitochondria, which is passed down from mother to child and can be used as a kind of genetic marker among large populations. The team of Spanish and Italian scientists were surprised to find out that the mitochondrial DNA of sub-Saharan Africans started showing up in Europe more than 11,000 years ago, and that more than a third of the African lineages found in Europe today have been there since before the days of the Roman Empire. One possible explanation, they said, is that Europe's Ice Age climate led some Europeans to head southward, but in any case, the findings may mean that we have to rethink some of our assumptions about human migration. Also, inside people, we're all just DNA. Finally, I'm throwing in a new segment here called Since You Asked, because, well, you ask some great questions about news, and they deserve answers. So a few weeks ago, I told you about efforts to clean up radioactive waste at Japan's Fukushima nuclear power plant, and you had some downright interesting ideas about what to do with it. Some of your suggestions, like feeding the waste to honey badgers and tardigrades, didn't really pan out scientifically. But a lot of you ask, can't we put it in a huge green garbage bag and hurl it into the sun? Or words to that effect. Some suggested sending it to the moon or to Mars, but launching it into the sun seemed to most of you to be the way to go. So since you ask, the fact is that the US government actually researched waste-to-space scenarios a long time ago, and the answer then was the same as it is now. Too expensive and way too risky. See, the consensus among rocket scientists, and yeah, I'm talking about literal rocket scientists here, is that rocket launches have a failure risk of about 1%. Now, 99% odds of a successful launch may sound pretty good, but consider when your payload includes radioactive isotopes with a half-life of over 30 years in the case of cesium-137, which is found in the Japanese waste, or 24,000 years for plutonium-239. Now imagine for yourself that 1% scenario in which, say, a few hundred pounds of this stuff was released during a bad, explosive, messy launch high in the atmosphere, where it will stay for months circulating around the world, raining radioactive dust down on everything. And then putting the risk aside, thinking of how many trips it would take. The US alone has 41,000 metric tons of nuclear waste in storage, and the rocket with the biggest payload capacity ever, that's the Saturn V, had a capacity of about 120 metric tons. So that's like 340 trips, and it costs between $10,000 and $20,000 per pound of payload. So you don't have to be a rocket scientist to see how that's not gonna work. Plus, there are some people who are concerned that the mission might mess up and somehow miss the sun, and then there would be a risk of putting the waste into an orbit that would eventually cross the Earth's path, which brings me back to the fact that the last thing we need to be worrying about is stuff like black holes or radioactive rockets colliding with the Earth. But hey, apparently the idea was good enough that the US government and rocket scientists have already been looking into it, so keep sharing your ideas and questions and feedback in the comments, and we'll see you in 2 weeks.